Hello and welcome to Spring 3.0 training. This is chapter 2, aspect oriented programming. Let's quickly run through the content of this chapter that we are going to look at. The content being, first we need to understand a little bit of what aspect oriented programming is, and we'll quickly see what was structured and what was object oriented programming, and then how we moved into aspect oriented programming. Once we have understood this, we'll look into AOP weaving. We'll look at some examples associated with it. Then we'll see how AOP aspect oriented programming proxying work, and once we understand the proxying, then we'll move on to some AOP terminologies like join point, point cut, advice, those kind of stuff, and then we'll look at the types of advices, and finally we'll look at the small code samples as well along for all these topics. So that's the content of this chapter. Let's begin with the first one. In the very beginning, there used to be the structured programming technique, and in this structured programming technique there used to be two important aspects. One was the functional programming and another was the procedural programming. So functional programming was everything was embedded inside functions, and there was the data versus a function relation was that every function had some data associated with it, some local data associated with function, and there was some global data being maintained along with the function. So there used to be a main point where the program used to start, and after that the program used to go to function, this to this function, this to this function, and then whole chain was followed upon, right? This is how the programming used to work. Now structured programming was combination of functional as well as procedural programming, and in fact much more else than functional and procedural programming. So it basically means that explicit control flow structures rather than the traditional jumping about directly from instructions to instructions, which we used to do in machine level programming. Instead of that, we divided code into different reusable components, and we moved from one control flow structure to another control flow structure, and then we were also handling the data in between. So functional and procedural programming are both in that sense a structural paradigm. From structured, we moved on to object-oriented programming. In this world, what we did was we encapsulated the data and associated function inside a class, inside an object. So class was just the blueprint, and object was the physical thing which used to be in the memory. So class used to define what will be the property and behavior. Property and behavior of that object will be, and then there were multiple objects. Everything in the system was an object. That's how we saw the Java world. So that was the object-oriented programming paradigm. There were pros and cons of these two structures. I won't go through all of these points because it will be too boring. So I'll advise you to just pause the video here and just go through it. The most important aspect was that ease of modification in the object-oriented programming world and managing the complexity. These are the two things which simply made the whole structured programming redundant. I'm not saying structured programming is not being used. It's still being used in lots of development across the world, but this is gradually declining, and this is the thing. I'm just comparing and contrasting between what was the traditional programming structure and how object-oriented programming evolved on top of that. Now that we have talked about structured programming a bit, and we have compared it a little bit with object-oriented programming, let's see the difference between OOP and AOP, the aspect-oriented programming. We need to understand what aspect-oriented programming is. OOP, object-oriented programming, is everything is a class, and these are all the application code. Now the problem is that application code is sprinkled with secondary and cross-cutting concerns. There are two types of concerns that we normally have. The first is the primary concern, which is, say for example, the core code itself, and then there is a secondary concern. Primary concern being your business logic. Say for example, if it is a banking domain, you are doing a payment. Doing the payment is your primary concern, and if you are adding a security on top of it, transaction management on top of it, logging on top of it, auditing on top of it, these are all secondary concerns, also called cross-cutting concerns. So OOP does not take care of these kind of things. So if you are writing a class, your class is still sprinkled with various concerns, but what AOP says is, no, my business logic will be like this. I will only write payment here. I'll only write some kind of statement management here. I'll only write some kind of card details here. I won't sprinkle my code with this, or with this, which are all secondary concerns. This is the business logic. This is something, say for example, if you have a shopping cart, adding a product, removing a product, calculating the cost is your primary concern. Auditing and security are your secondary concern. So I'll only do addition of the stuff in the cart in my main code. I won't sprinkle each and every class with all types of code. These are all my primary concerns. That is one aspect, that is the business. And then I'll divide rest of the secondary concerns, cross-cutting concerns, into various aspects. I'll call it security, I'll call it transaction management, and I'll call it auditing. So I'll divide my code into two different aspects: primary concerns and secondary concerns. AOP is not something which replaces OOP, it complements OOP. Aspect-oriented programming complements object-oriented programming by providing another way of thinking about the program structure than just the class and object, then just the properties and behavior, then just the data and the method. The key unit of modularity in OOP is class, whereas in AOP the unit of modularity is aspect. So aspect enables the modularization of concern. You can't say that I won't do AOP anymore and I'll just write everything in aspect oriented programming. You will be doing OOP, and on top of that you will be adding AOP as well, which will make your code, instead of looking like this, your code will look more like this. So that's aspect oriented programming, and pictorially if you want to represent it, it will look something like this. This is the base program. When I say base program, what I mean is this primary concern, the base program. When I say secondary concern aspects, these are this program which is sprinkled across the code of AOP. We will see what point cut definition is. So it says, okay, I want to add something here. Aspect is inserted. So this is the additional advice that we are saying. This is inserted in between, and now the code looks like this. This is the extended program. If you pictorially want to see it again, this looks like this. You have the actual code, the main business logic, the stuff in blue. It has a method A, method B, and you have aspect A, aspect B, your security, your transaction management, your auditing, your logging. You do a weaving of these two codes together, and once the weaving is complete, the aspect is attached to method A, aspect B. It is just an example. You can attach aspect A in both method A and B, and you can attach aspect B in both method B as well. We'll see the details of it, how an aspect can be attached to some methods and to some types. But for example, this is just an example which says that base code, primary concern plus secondary concern are weaved together to generate proxied object or advised object or target object, and then when they are weaved, they look like this. Another example is, this is your source code, you give it to compiler, you get the executable. But now you have source code, you have aspect, you weave them together, you get the weaved class, you give it to compiler, which ultimately gives you the executable. That's how it looks like. So that's what is AOP weaving. It's the weaving of two aspects. Now you have created, this is actually how you want the execution. Even though it is sprinkled, I cannot break the sequence. All I can do is, I'll just divide it into two different sections, but I will still want at this place my code to be executed. This light yellow color should actually be executed here because it is supposed to be executed. You can't change the business logic. You can't change the auditing and logging and security and transaction. All you can do is, you can divide it into two different parts, and a weaver, you can tell a weaver, even though my two codes are separate, what I want is, you take this and you take this and you make sure the code is executed at this point of time. That's what is weaving. So we are weaving the primary concern and the secondary concern together to create proxied object, advised object, or the target object. That's what is AOP weaving. Let's quickly see the code bit of it. Let's start with the sample advice. Now you understand what is advice. So what we have is, we have a very basic example to understand it very clearly. There is an application which has a very simple method. It says sysout. Now what we want is that the moment this class runs, I want something to be executed before it and something to be executed after it, even though I have not coded it inside it. So I have an aspect called sample advice, and sample advice has two methods, insert before and insert after. So the moment this method is run, I always want that this method of this class should always be preceded by this method, and should always be once the completion of this method is done, this method should be executed. So I want to weave this primary concern with the advice. Clear? And what is this? What is advice? Advice is nothing but implementation of an aspect. So this is an aspect which is represented by advice. Advice has two methods, before and after, and this is my primary concern. In this primary concern, I am saying that I want to weave this advice. Very simple, very straightforward. In the AOP config, how do we do it? We are starting with XML config. So in XML config, you have the standard beans/beans definition. You have test application definition. Ignore this for now. So you have the test application definition, and then you have the advice definition. So this is your primary concern, this is your secondary concern of the code. This is normally the business logic, and this is supporting functions. This is the magic weaving part. You're supposed to use the XML AOP namespace. This namespace will provide you a new schema, and in the jar you can look at the XSD. So if I scroll down further, probably in this you can see all these jars are associated with AOP. The aspect J Weaver, aspect J Tour, AOP Align, CGlib, aspect ASM, and AOP. So these are just apart from the core jars, of course, and the most important being in the core context. Core beans common logging is a dependency, so you can't run away from that. Expressions is also needed most of the times, and then if you are using a web application, then perhaps you'll need web and web servlet. If you are using any other things, JDBC, JMS, or ORM, then probably you'll need rest of this as well. Coming back to XML, that's the XSD definition that you're supposed to use, and that will give you AOP config tag. And within AOP you have an aspect. An aspect references sample advice. So what you're saying is, who is my aspect, who is my secondary concern? I am saying sample advice is something I want to weave in the primary code. And now we are saying there are two things. We'll get into the details of what point cut is, what before is, what after returning is. For now you can understand that where you want to weave. We'll pictorially see what point cut means actually. So this is an expression which defines the location where we want to weave it. So it's like saying that, okay, I want to weave before method A and before method B. So this expression is telling that any method which begins with test method and has parameters, intercept those methods, and at those locations before that you call insert before of sample point cut, and you call insert after sample point cut. So what this AOP config is saying, this AOP config is saying that I want to weave sample advice in the code, in the application code, and the application code pattern would be wherever you find a method, test method, which begins with test void, has a public void as the beginning of the method signature, has some parameter, can have or cannot have parameters, then you insert this point cut before and after. So you insert before and after to this sample point cut. This method is insert before method, and this method is insert after method. This is the advice that we have seen, insert before and insert after. This XML is very important to understand. All we are saying is how these two objects will be weaved together. So you are defining a point cut. This point cut tells you where the weaving will happen in the primary concern, and this is saying the secondary concern methods will be weaved here. And of course these methods are there in your advice. Ultimately you are simply saying AOP config.xml test application, and you are running your primary concerns method, test method. You are running this method, test method. What do you expect? You expect, because of this weaving, this code will be executed before, your primary concern will be executed, and this code will be executed afterwards. Let's quickly run it. Spring has loaded from AOP config. Now see what's happening. Inserted before method, this primary concerns method, and after method. Very basic stuff. That's all that happened, and the whole magic is here. Don't worry about this. We'll see the point cuts in details. We'll see the expressions in details. We'll also see how what are the different types that you can do.